Hello friends, welcome again. Let's talk about advanced Kubernetes, and the first we would be taking Kubernetes API. Now Kubernetes API serve as a foundation for declarative configuration schema for the system. Kubectl command line tool can be used to create, update, delete and get API objects. Kubernetes API act as a communicator among different components of Kubernetes. Let's talk about adding API to Kubernetes. Now, adding a new API to Kubernetes will add new features to Kubernetes which will increase the functionality of Kubernetes. However, alongside it will also increase the costs and maintainability of the system. In order to create a balance between the cost and the complexity, there are a few sets defined for it. The API which is getting added should be useful to more than 50% of the user. There is no other way to implement the functionality in Kubernetes. Exceptional circumstances are discussed in the community meeting of Kubernetes and then API is added. API changes. In order to increase the capability of Kubernetes, changes are continuously introduced in the system. It is done by Kubernetes team to add the functionality to Kubernetes without removing or impacting the existing functionality of the system. Let's demonstrate the general process here in a hypothetical example. As you can see in the screen, and we can read out a few of these. A user posts a pod object to API v7 beta 1. The JSON is unmarshaled into a v beta 1 pod structure and so on. Now that we have the pod object stored, a user can get that object in any supported API version. For example, a user gets the pod from API v5 and the other is the JSON is read from etcd and unmarshaled into v6.pod structure. Default values are applied to the v6 pod. The v6 pod is converted to an API pod structure. The API pod is converted to v5 pod structure. And the last one is the v5 pod is marshaled into JSON and sent to the user. Now, the implication of this process is that API changes must be done carefully and backward compatibly. Let's talk about API versioning. To make it easier to support multiple structures, Kubernetes supports multiple API versions, each a different API path, such as \API/v1 or \APSI extensions \v1 beta 1, as you can see in the screen. Now, versioning standard at Kubernetes are defined in multiple standards. One of the levels can be alpha level. This version contains alpha, example v1 alpha 1. Second can be this version may be buggy, the enabled version may have bugs. Third, support for bugs can be dropped at any point of time. And fourth, recommended to be used in short-term testing only, as the support may not be present at all times. Now let's talk about beta level. The version name contains beta, example v2 beta 3. The code is fully tested and the enabled version is supposed to be stable. Third, for beta level is the support of the feature will not be dropped. There may be some small changes. And finally, recommended for only non-business critical uses because of the potential for incompatible changes in subsequent releases. Okay, so we have covered alpha level, beta level. Let's talk about stable level. The version named is Vx, where x is an integer. Stable version of features will appear in the release software for many subsequent versions. Okay, so that finishes API. Let's quickly move to Kubectl. Now, kubectl is the command line utility to interact with Kubernetes API. It is an interface which is used to communicate and manage pods in Kubernetes cluster. One needs to set up kubectl to local in order to interact with Kubernetes cluster. Now, setting kubectl. To set the kubectl, download the executable to the local workstation using the curl command. Now, the commands are as written on the screen. On Linux machine, the command would be this, as I'm pointing out through my cursor of the mouse. On OS X workstation, it would be like this. After download is complete, move the binaries in the path of the system. Here it is. And finally, configuring kubectl. Following are the steps to perform the configuration operation. So these are the for configuring kubectl. Now, a few of the points which are of great importance when we talk about this. First, replace $master host with the master node address or name used in the previous steps. 2. Replace $CACERT with the absolute path to the CAPEM created in the previous steps. Third, replace admin key with the absolute path to the admin key.pem created in the previous steps. And fourth, replace admin cert with the absolute path to the admin.pem created in the previous step. Okay, so let's verify the setup. To verify if the kubectl is working fine or not, check if the Kubernetes client is set up correctly, and this is the command for the same, as you can see at the bottom. Okay. Now, with this, let's pause and end this lecture. And in the next lecture, we would be talking about Kubernetes associated properties, more commands, and things related to that. Till then, thank you very much.